Welcome to Chem Mastery with Dr. G. In this video, I'm going to talk about the collision theory and the factors affecting the rate of chemical reactions. So, what are the factors affecting the rate of chemical reactions? First of all, we need to understand what is the collision theory. First of all, any chemical reaction to start or to happen, you need the particle to collide with each other with sufficient energy. So there's a theory called the collision theory, and it states that chemical reactions can occur only when reacted particles collide with each other and with sufficient energy. So the rate of a chemical reaction will depend on two main factors. The first one is the collision frequency of reacting particles, meaning how frequent the particles can collide with each other. So the more the collision, the faster the rate of the reaction or the faster the reaction. And the second factor is the energy transferred during the collision. So the higher the energy of the particle when they collide with each other, the faster the reaction as well. We know that for any reaction to start, there is a minimum amount of energy that is needed, which is called the activation energy. So the activation energy is the minimum energy that is needed for a reaction to start because it's needed to start breaking the bonds between the reactant and to form the products. Any factor or the factors that either increases the number of colliding particles or increase the frequency of collision, or that will increase the energy of particles when they collide, will ultimately increase the rate of the reaction or make the reaction faster. So there are five main factors that affect the rate of the reaction. The first two are the concentration of a solution or pressure for gases. So normally we can measure the concentration of a solution, but we don't do that for gases. So for gases, we usually deal with pressure. And then there's the surface area of the reacting particles or of the reactant. The fourth factor is the temperature of the reaction, and finally the catalysis or the use of a catalyst. So let's start talking about these factors one by one. So the first one is the temperature. And increasing temperature will increase the rate of the reaction. The main reason for that is that when the temperature increases, the particles will start to move faster. And if they move faster, that means that they can collide with each other more frequently. So this will increase the frequency of collision of the particles. Also, when the temperature increases, that means the particles, when they move faster, that means they have more energy, so they have higher energy. And if they have higher energy, then that means when they collide with each other, they will have enough energy or energy higher than the activation energy, so the reaction can actually take place. So we can see here in this figure that at lower temperature, there's only one effective here, this representation. You can see that there is only one effective collision between the particles. But when we increased the temperature, because particles moved faster, then they started to collide with each other more, and there have been more effective collision between the particles, and then the rate of the reaction will be faster. So the second factor is the pressure and concentration. So pressure for the gases and concentration for the solutions. So increasing pressure or increasing concentration will increase the rate of the reaction. The main reason for why increasing concentration will increase the rate of the reaction is because if a solution is more concentrated, that means more particles will be colliding with each other because we have more particles within the same volume of solution. So more probability of collision. For gases, increasing pressure will also increase the probability of collision. The main reason for that is the higher the pressure, that means we have the same number of particles occupying smaller volume, so more probability of collision. Both of these will make the collision of the reactant particles more frequent, so the rate of the reaction will increase or the reaction will become faster. So as we can see here, there is less concentrated solution or lower pressure for gases. And if we increase the concentration or pressure, we have more particles, so more effective collision between the particles and faster rate. The fourth factor is the surface area. So increasing surface area will increase the rate of the reaction as well. The main reason for that is that when you break the particles into smaller ones, that means the other particles will have more effective surface area to work on or to collide with, so that we will have more collision, and then we're going to have a faster rate for the reaction. The surface area to volume in this case will increase, and if the surface area to volume increases, then that means more probability of effective collision or more probability of collision. So if you can see here, this is the particle with the low surface area or the big size, and there are less surface area for the collision. So here the surface area to volume ratio is smaller, but when you break down the particles into smaller ones, then you increase the surface area, and there will be more effective surface area for the reacting particles to collide. So more frequent collision and more effective collision as well. The last factor is the use of a catalyst. So catalysis or the use of catalyst will increase the rate of the reaction. The main reason for that is because catalyst will reduce the activation energy of for the start of the reaction. So what is a catalyst first? A catalyst is a substance that will speed up the reaction without being used itself in the reaction. And normally different reactions will need different catalysts. So catalysts work by decreasing the activation energy needed for the reaction. And they normally do that by providing an alternative pathway with lower activation energy. So let's see the difference between the use of a catalyst and a reaction profile without the use of a catalyst. So this is the diagram for the reaction profile, where we have the reaction progress on the x-axis and the potential energy or the energy for the reactants and products on the y-axis. This is the initial energy for the reactants, and here is the initial energy for the products. And we know that for the activation energy for the reaction to start, there must be an increase in the reaction, which is called the activation energy, until we reach that. So the reaction will start, and then the energy will start to decrease until we reach the energy of the product. So this is the activation energy for the reaction without the use of the catalyst. This is the normal one. So here, no catalyst. But if we use a catalyst, there will be an alternative pathway. There will be a reduction in the activation energy. So the activation energy will be less in this case. And then the activation energy, as we can see, is only this part or this difference. So this is when we used with the use of a catalyst. So we can see that there is a difference in the activation energy when we didn't use a catalyst and when we used the catalyst. So a catalyst will reduce the activation energy. If we reduce the activation energy, then that means more effective collision. Even though the number of collision may not change, but effectively, more effective collision will be there. So because the activation energy will be lower. So this is how the use of a catalyst will increase the rate of the reaction.